Welcome, everyone. Today, we are embarking on a fascinating journey through the evolution of agency, focusing specifically on the massive paradigm shift from traditional chatbots to fully autonomous AI agents. Let's get started. Let us kick things off by defining what this evolution actually means. For years, we relied on chatbots. Chatbots, like the early versions of ChatGPT, are conversational interfaces optimized for dialogue management and turn-taking. They are fundamentally reactive. However, generative AI agents differ from general-purpose LLMs because they engage in complex actions and autonomous planning. As AI pioneer Harrison Chase notes, an agent is created when an LLM decides the control flow of an application. Instead of following a fixed sequence of events, agents are proactive. They take natural language input, decide which tools to call, orchestrate multi-step workflows, and return results. We are moving from a world where AI simply talks to us to a world where AI does real work for us. Take a look at this flowchart. On the left, we have traditional chatbots, which are purely reactive and rely on conversational turn-taking. As we move to the middle, we see copilots, which are task-oriented and assist humans in specific domains like coding or drafting. Finally, on the right, we reach autonomous agents. These systems independently make decisions, adapt to new information, and execute tasks with minimal human intervention. It is a clear progression from mimicking conversation to driving autonomous action. Why do we even need to move beyond standard LLM chatbots? The answer lies in their inherent limitations. Despite their advanced language capabilities, raw LLMs lack true understanding, functioning essentially as stochastic parrots. This makes them prone to hallucinations. They also struggle with complex, multi-step problem-solving and reasoning. Furthermore, their knowledge is frozen at the time of pre-training. They do not have real-time access to dynamic databases. Most importantly, they lack native tool use. They cannot interact with APIs or execute code on their own. To overcome these hurdles, AI systems must evolve from passive text generators into active agents that can reason, access up-to-date data, and interact with their environments. This diagram perfectly illustrates the transition. At the top, you see the isolated LLM, constrained by static training data and an inability to act. The red arrows show its limitations, hallucinations, and isolation. But when we transition to the bottom structure, the agent, we surround that same LLM with external integrations. By connecting the LLM to APIs, vector databases for retrieval, augmented generation, and calculation tools, we bridge the gap between raw cognitive capability and practical, real-world action. How exactly do these autonomous agents work? Think of an agent as having a distinct anatomy. At the center is the brain, or the LLM, which serves as the core processing unit for interpreting data and performing complex inference. Next, we have perception, or the sense component, which is how the agent gathers contextual information from digital or physical environments. Once the agent senses its environment, it uses its brain to plan a sequence of steps. Then comes the act phase, where the agent executes its plan using available tools, like calling an API or running a script. Finally, memory stores the agent's past experiences and internal state, providing context for future decision-making. This continuous sense-reason-plan-act loop is what enables true autonomy. This circular diagram visualizes the agent's operational loop. It starts with sense, where the agent perceives the environment. This data flows into the reason and plan nodes, where the LLM processes the input and decides on a strategy. Next, it moves to act, where the agent uses tools to execute the strategy. Notice the central memory node. It interacts continuously with the loop, ensuring the agent learns from past actions and maintains context. This feedback mechanism allows the agent to adjust its behavior over time. Let us take a deep dive into how agents orchestrate their actions using the ReACT framework, first proposed in 2022. ReACT stands for reasoning and acting. It interleaves these two processes in an iterative loop. First, the model generates a thought to analyze the current state. Then, it takes an action by selecting and invoking a tool. Next, it receives an observation, the result of that tool. It repeats this cycle until the goal is met. For example, in LangGraph, you can implement this effortlessly. You simply define your tools and initialize the agent using create react agent, model equals LLM, tools sad face search, calc. This simple setup allows the model to dynamically adjust its plans based on new information, making it incredibly powerful for exploratory scenarios. Here is a classic React loop mapped out as a state diagram. You can see the user input triggering the first thought node. The LLM reasons about what to do next, which points directly to the action state where a tool is executed. The result flows into the observation state, providing feedback from the environment. If the task isn't complete, the loop cycles back to thought, allowing the agent to update its strategy. This continuous loop prevents the model from just guessing. It grounds every step in real-world observations. Knowing when to use an autonomous agent versus a traditional workflow is a critical design decision. Agentic workflows guide an application through a fixed sequence of predetermined steps. If your task is deterministic and you can enumerate all decision branches in advance, use a workflow. However, agents dynamically select tools and determine the next steps based on evolving context. If you face high variability, open-ended reasoning, or dynamic planning needs, invest in an autonomous agent. The ultimate trade-off is between control and flexibility. Workflows are easier to debug and highly predictable, while agents excel at handling unstructured inputs, parallel task orchestration, and adapting to unexpected roadblocks. This split-screen decision tree highlights the difference. At the top, a task is received. The critical question is, are the steps fully predictable? If yes, the flow moves to the left, an agentic workflow with fixed routing. It is predictable and safe. If no, the flow moves to the right, an autonomous agent. Here, the central LLM evaluates the state and can dynamically jump between tools and memory, creating a unique path for every user request. Use workflows for strict compliance and agents for complex problem-solving. Let us look at a highly impactful real-world use case, automating a loan origination pipeline. A financial institution needs to handle unstructured data, enforce strict risk guidelines, and maintain compliance. A single, monolithic agent would struggle under this cognitive load. Instead, we use a hierarchical multi-agent architecture known as the supervisor pattern. A loan orchestrator agent receives the application. It doesn't do the checks itself, it delegates. It sends documents to a specialized document validation agent, then routes the ID to a credit check agent, and finally sends the financials to a risk assessment agent. The orchestrator gathers all outputs and makes a final, auditable decision. This makes the entire workflow modular, auditable, and incredibly efficient, drastically reducing manual review times. This hierarchy chart displays the supervisor architecture in action. At the top, the loan orchestrator acts as the project manager. It branches out to 3 specialized workers: the validator agent, credit check agent, and risk assessor agent. The orchestrator delegates tasks downward, and the specific results like validation status or credit scores flow back upward. This ensures that each agent only focuses on its specific domain, keeping the system scalable, governable, and exceptionally easy to debug. As we look to the future, we are moving rapidly beyond single agents into advanced multi-agent systems and emergent swarms. In these highly mature, Level 6 systems, agents will autonomously form ad hoc teams, debate hypotheses, and negotiate resources to solve incredibly complex challenges without a central human manager. They will engage in continuous self-improvement, using reflection patterns to critique and refine their own reasoning over time. Understanding this evolution from simple chatbots to complex, collaborative agent societies is paramount for any technology professional aiming to stay relevant. That wraps up our training today. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram illustrates the evolution of agentic maturity. We start on the left with a single agent, which is effective but limited in scope. We move to the center with a hierarchical multi-agent system governed by a supervisor, offering structure and specialization. Finally, on the right, we see the emergent swarm, a decentralized web of agent nodes communicating dynamically, representing the cutting edge of autonomous AI capabilities. Thank you for watching.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft. certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.